Hi everyone, in this video I will create the volume surface which will allow us to calculate the amount of cut and fill and create a balance between the cut and fill volumes. To create a volume surface, very similar process to a standard surface. We go to surfaces and create a new surface, or by right clicking on surfaces and create a surface. This time we will create a volume surface rather than a plane surface. So for a volume surface, first of all, as usual, we'll give it a name, cut and fill. And for the style of the surface, we will choose the cut and fill banding. That will create a color bands for the amount of cut and fill. And this volume surface is different from the plane surface or the two-dimensional surface by having a base surface and comparison surface. So the base surface obviously should be our existing ground. That's what our original existing surface. And the comparison surface, we will choose our corridor surface. By choosing the corridor surface, that will allow us to work out the difference between the new surface we created for the corridor and the existing surface, and that will create the quantities of cut and fill. Now, in terms of the cut and fill factors, usually when you cut an amount of natural soil, let's assume that we cut about 1 cubic meter of natural soil. When you try to fill that amount of soil, it will require slightly larger volume to fill that same amount of cut material. So if we cut about 1 cubic meter of soil, that will require about, say, 1.1 cubic meter to be filled. And the reason is just this natural soil has been compacted for millions of years, especially natural soils has been compacted for a long time, has a higher density. We try to do our engineering compaction for the fill material, but it's almost impossible to reach the actual natural status of the compaction. So I will allow about 10%. That tells us that when we cut about 1 cubic meter, that will require a volume of 1.1 cubic meter to be filled in. So as usual, we created our surface just in this area here, the difference between the existing ground and the corridor, that's the boundaries of that surface. By creating that surface, really we haven't achieved anything. As you can see, nothing has been changed other by showing where the surface is. To start with, one of the main things that we should do, like usual, we right click and we analyze that surface to show us the amount of, or the areas of cut and areas of fill. By going to surface properties, we go to the analysis, and we are analyzing elevations, which is the height of the surface, and we choose range of intervals with datum, and the intervals I'll choose 200 millimeters, so 0.2. By clicking on run the analysis, that will create the analysis for the surface. As you see now, the surface will change in color, will show us the amount of cut and fill, or the areas of cut and fill along the surface. Analyzing the surface yet doesn't give us any tool to make any changes or calculation for the amount of cut and fill. In order to do that, what we have to do, we have to add our surface to what we call it the volume dashboard. Okay. One way to do it by just clicking on the surface, and that will open the contextual ribbon for this surface. Part of it will be the volume dashboard, or you can go to analyze and volume dashboard. Our volume dashboard, if you see is your menu like that, by clicking on here, that will show you the indicator of the amount of cut and fill. And currently our dashboard is empty, we don't have any volume surfaces here. By adding a new surface, we only have one volume surface, the cut and fill. By adding that, that's showing us on that dashboard how much the amount of cut and fill. As you can see, we have large amount of cut, small amount of fill. So if we keep this, usually I'll keep this on the second screen, but for now, so we can see it on the video, I'll keep this indicator here. And one of the main ways to change our cut and fill is to adjust our profile. As we agreed, this hatch of cut and fill doesn't give us accurate estimation because this is looking at the profile as a 2D profile, 2 dimensions only, as if the road is one line, doesn't give it a third dimension for the width of the road. For example, in this area here, part of the road in one location at one station, part of the road in the fill, like the center here, the green, and the other parts here on the side under the cut area. This tells us that this view here doesn't give us accurate estimation for cut and fill. It just shows us, as for example here, shows us there's cut only, just for the center line. So in order to adjust our profile to achieve the right balance between the cut and fill, usually we look for a balance of no more than 10%. We can, on the software, it's easier now to achieve about 0 net difference between the cut and fill. So this is our net quantity in cubic meters, and this is the amount of fill, and this is the amount of cut. To do that, we can start adjusting our profile. One of the handy tools, first of all, obviously here we are adjusting the height of the profile for the proposed road. One of the important tools that you can use is the vertical intersection point here, and we've got 3 grips to allow us to move along the profile for the same grade here for the tangent before the profile, or in the other direction here for the tangent after the profile. We can move the intersection point up and down, and usually this tool by itself is sufficient to provide enough change with our amount of cut and fill. I just realized here the cut and fill surface doesn't give us a automatic update, simply because I did not click here and create rebuild automatically, and the same thing I've got for the finished ground. One of the other tools that we can use by changing the size of the curve, the length of the vertical curve. Having said that, this doesn't apply large change to the amount of cut and fill, mainly changing the height of the profile what will make that difference. Now I'd like just to make sure to draw your attention that moving this handle here, we shouldn't do that, mainly because if I do that, as you can see here, if I change this, if you focus with me on the start or the end of the profile here, by moving this handle here, that's changing the height of the entire tangent. That means the starting and the ending point are changing. As we know, it's very important to keep this connection here between the proposed profile and the existing ground, otherwise that will create a large drop in our corridor, because we will have a small area. So if I do that, just to show you the outcome, by doing that, first of all, that will create large problems. As you can see, start getting some errors in here, showing us on the events that gave us errors, and that's mainly because we've got an area here of our proposed corridor doesn't have any elevations. It's not connected to the existing ground. If I look at my corridor now, just by looking at the corridor in a 3D view, this is the drop we were talking about. So if you see something like this on your corridor, make sure to go back to your profile and fix that issue there. So to make sure that's fixed, always we have to have, as we agreed earlier in the previous video, please go back to the profile videos. We have to make sure this will be moved. Our auto snap will be turned off, and shift right click. We've got the end point that will snap only to that one point here, and that will fix these events that we had for the error. I'll show you that. So if I clear, and that's already gone. Okay, so now for adjusting, that's the whole point I tried to make, that please do not change either this handle or that one. What you can do, you can adjust the height of the end of this tangent by moving the curve up and down. Okay, so as we can see, we still have more area of cut and less area of fill, and by just adding a bit more of the fill area. That's going in the right direction, but a bit too much. I'm always looking at this number here, trying to make this number as small as possible. If we can make it to 0, that would be even better. So I went too much in the other direction. This minor adjustment now, I still have more area of cut, less area of fill. So if I make this slightly larger, that will make very minor adjustment, and we are down to 408 cubic meter. That's 275, 257. We'll add a bit more, make the curve larger. That's it. We are almost near 0. Went to the other direction. Okay, so I'm happy with this. That's almost a balanced volume between the cut and fill. Very small difference between the two. Now, one of the main things that we need to keep an eye on is our K value. Shouldn't go below the K value that we had initially chosen for our profile, and that will depend on your speed of the raw design speed. Also, we have to make sure the start and the end point are in the right location. One of the other things that we should keep an eye on, which is the slope of our tangents, or the gradient of our tangent. In this case here, we have a very small gradient. It's not recommended to have that. Usually we try to make sure that we have no gradient less than 1%, maybe 0.5%. So this may imply to lower our corridor here a little bit. Having said that, in this case we have the cross fall on our road is 3%, so that shouldn't be a problem for our road. If we find an issue with that, we can always try to adjust our profile height to create that a longitudinal fall on our road. Okay, up to here, first of all, let me just change the scale so we can see these annotation in a slightly larger format. Up to this point here, we've got everything sorted. One of the other issues that I would like to draw your attention to, choosing your corridor surface, making sure that when you had your corridor surface here, so if I select the corridor mainly and go to your corridor surface, if you had your corridor, you must have your boundaries set up, because if I delete this boundary here, so if I remove that boundary, apply and OK, that will change in a large amount of my quantities of cut and fill, and that will give me a false information. So make sure, if you have an issue like this, that your corridor surface is set correctly with the right boundaries. So that's just by selecting your corridor and go corridor surface, under the boundaries right click, creating the corridor boundaries to be the extent of the corridor, the actual corridor boundaries. Apply and OK. And that's it really, guys. This is for our cut and fill volumes calculation. Now, just one of the last steps that we can do. First of all, we usually send this to back in the display order. We send it to the back to make sure it doesn't interfere with all the information that we have in front of it, the cut and fill volumes. One of the last things that we can obtain from this process is a report for our amount of cut and fill. By the way, just to draw your attention, this cut and fill factors, we have them here on our dashboard, and you still have the opportunity here to change those factors for any value that you desire. Because, for example, for sand, it wouldn't be around 1.1, it could be close to 1. So the same volume we can cut from one place, we can fill in another place. So it depends on the type of the soil that you're working with. These factors may change. And finally, just so we can create a formal report for the amount of cut and fill, by clicking on this option here, that will give us our report for the quantities of cut and fill and the difference between the two. So we've got amount of 35,000 of cut, 35,000 of fill of cubic meters, and the difference between them will be about 60 cubic meters. Okay, so usually we do desire to keep an extra amount of fill that we need for other application, or we might desire to have an extra amount of cut because we have excess soil from a different location that we want to use it in this particular project. So that's to give you a quick way to estimate your cut and fill on a road design. Hopefully that will help you guys. If there's any questions, please let me know.